All right, for this worksheet, which is the second ANOVA worksheet, we've already done some calculation once. What we're going to do in this worksheet is to go through a couple more versions of this to give you guys some practice, and I've asked you a few additional questions. So let me first clarify the questions after I read this first story problem. So here, a research study was conducted to examine the clinical efficacy of a new antidepressant. In other words, does the antidepressant work? Depressed patients were randomly assigned to one of three groups: a placebo group, a group that received a low dose of the drug, and a group that received a moderate dose of the drug. After 4 weeks of treatment, the patients completed the Beck Depression Inventory. In other words, the outcome here is depression. The higher the score, the more depressed the patient, and the data are presented below. Compute the appropriate test. So what we see here is these are all the depression scores in the placebo group. These are all the depression scores in the low dose group, and these are all the depression scores in the moderate dose. And what we want to know is, are these groups different from one another? So I've asked a couple different questions of you. The first question is, what is your computed answer? This may seem a little bit strange, but I just want to point you in the right direction. Your computed answer is going to be your F score right here. What is your computed answer? That simply means what is the F statistic that you get at the end. So you need to do a lot of work before you actually get to this F score. Remember, part of what you're going to do is you are going to calculate out each of the different sum of squares. So what I've done for this one, and you won't get this on the test, but I've kind of set you up here with a table that is labeled and already slightly filled in. Now on a test, what you would end up getting is you get a table, but it wouldn't have anything written here, and it wouldn't have anything down here. It would be up to you to fill these parts in. It would just be a blank table that you could then use. But for this assignment, what I've done is I've tried to give you this table. So what you need to do is to take this data, as you did with your last exercise, and you need to figure out first, what in the world does x minus m mean? Well, if we go down to, and you'll see remember, this is a sum of squares within table. This is what we're trying to calculate. So if I go down all the way to the end where I have my kind of cheat sheet here, what I find is the sum of squares within is the sum of x minus m squared. What does that mean? X is my individual score, and m is the group mean. That's the average of the scores within a group. It can be represented as a mu. We're going to represent it as the big M. Okay, so what I need to do for this is to calculate the difference between, so if I come up here, back to the first table, the difference between the individual score and the mean. So for each one of the participants, they have an individual score right here, and they're going to have a mean value. Now, I haven't gone through and calculated this. Remember, the mean of the placebo group is simply what I get by averaging all of these. So by averaging all of those scores, it's going to give you the mean of the placebo group. And so what I'll do for this person is to calculate out 38 minus that mean score. Okay, when I get to it, when I finish it, then what I'm going to do is to square it. So I'll take that and square the value, and I'll do that for every other participant. And in the end, sum up all of these squares to get the sum of squares within. Okay, the second thing that I want to do is I want to specify what would be the null hypothesis in this study. What is the null hypothesis? Well, maybe even better to start with, what's the alternate hypothesis or the experimental hypothesis? Here we have three different groups that are getting different kinds of treatments. The alternate hypothesis is that these groups will differ in their depression level. So what's the null hypothesis? It's the party pooper of the group. They won't differ. Next, you're going to think about what probability level did you choose. By probability level, we mean p-value. And why? What is your F critical value? You're going to need to use one of those F the tables of critical values for the statistic F. You can find this simply by Googling it, or there's also one in your book. Next, you're going to conclude by comparing your computed answer with your critical value answer. You're going to conclude, is there a significant difference between the groups? And if there is a significant difference, what do those differences appear to be? Now, what I want you to include is this phrase: although post hoc tests are necessary, there appear to be differences such that this group is higher than this group. So remember, we always need to use a t-test to compare two different group means. But right now, I'll allow you to do a tentative answer if you include that phrase. And then last, you want to interpret your answer. What does this mean in the course of, for instance, diagnosing individuals with depression and then giving them a drug treatment? Which one would you recommend? You'll do this for each one of the problems, and we'll compare your answers in class.